welcome to another episode of LCA Physics, and this is the first class period for the long distance learning that we're doing here for the spring of 2020. The new topic that we're going to start today is on waves. There's two general categories of waves. One of them is called mechanical waves, and the other ones are called electromagnetic waves. Okay, so there's two general categories. Now, under the heading mechanical waves, there are three different kinds of waves that fit into that category. And the reason they fit into that category is because all mechanical waves require a medium. Now, we may have covered this before, but the term medium is a word that means a type of matter. There must be a type of matter present in order for those waves to exist. Example, if you're thinking about the water waves that you see at the beach, the reason they exist is because of the water that they're being produced in. And if you're thinking about sound waves, whether you know this or not, sound waves could not exist if air wasn't present. So mechanical waves require a medium. On the other hand, electromagnetic waves, which are sometimes referred to as forms of light, do not require a medium. Do not require a medium. Now, why is that true? The electromagnetic waves are waves that are traveling, for example, from the sun to the earth. Those waves, which include light and visible light, UV light, gamma radiation, all of those things travel through the void or emptiness of space and go through our Earth's atmosphere, but they do not require a medium to be able to travel. And they can travel, from distant stars all the way to our planet without the presence of any kind of matter. And so these electromagnetic waves do not require a medium. Now, we'll talk about this one in a second. Let's go back to the mechanical waves. The three different kinds that we have here, number one is longitudinal. Longitudinal waves is a word that we don't generally use much, but the longitudinal waves, the example of those is most commonly sound waves. And we'll go into that in a little more detail in a minute. The second form of waves would be water waves. And we will discuss all the forms and so on of those types of waves. And the third one, which a lot of times people don't think of, but I'm going to use the term seismic waves. And seismic waves are going to be related to what? And you should be saying earthquakes. So the seismic waves, and there's several different types of seismic waves that are produced during earthquakes. There are several different types of waves that are being produced in water waves. And then the longitudinal waves. All three of these types of waves are going to require a medium. Now, if we step over here to electromagnetic does not require a medium, as we said before, but it falls under a category right here of light, which is the electromagnetic spectrum. So it involves several different kinds of light other than just the kind that we see. It starts out over here And we're going to talk about radio waves. And then we're going to talk about microwaves. And then there's a kind of waves that's called infrared. And then there's visible light, which is just one small section of that spectrum. It's very narrow. And then there's UV, ultraviolet. There's X-rays. And there is gamma all the way out here on the end. And we just got done talking about X-rays and gamma rays when we were referring to the unit on radiation that we did last week before we had this break in school. All of these waves, all are represented by electromagnetic waves, and sometimes these electromagnetic waves are said to be transverse. And we'll explain that a little bit more in just a second. Okay, so electromagnetic waves are transverse. And we're going to draw some pictures here to go along with that. Now, if you've got all that in your notes, then you're ready for video number 2. Thank you. Now let's see.